economies of scale explained. Some time ago already, I showed that there are advantages when you increase scale. These economies of scale are greater the more variability there is in the process and the desired level of performance. In this video, I will try to explain in simple terms exactly how this works. We are going to formulate this mathematically right away. Because there is variability, the demand, for example, for hospital beds or travel times will sometimes be larger than the average and sometimes smaller than the average. We can say, however, that we take the average as the starting point for the required capacity. So the required capacity is the average demand for capacity plus a buffer. That buffer depends on two factors, namely, as you already know, the degree of variability and the desired level of performance. We could then write the buffer as buffer equals alpha times standard deviation, where alpha is the desired level of performance, how often you still allow that the required capacity turns out not to be enough, and the standard deviation, a measure of the degree of variability. I won't go further into this right now. The expression alpha times standard deviation does exactly what we have seen. If there is a lot of variability, standard deviation is large, a huge buffer will be needed. But also, if you only want to turn out not to have enough capacity in a few cases, so the alpha is large, the more buffer will also be needed. If you want a very good performance, so alpha is large, but at the same time there is a lot of variability, so the standard deviation is large, then on the contrary a lot of capacity is needed. Therefore, it is also important to try to reduce variability. Now suppose we have two similar processes. For simplicity, they both have an average demand of 20 and a standard deviation of 4. Process 1 then has a required capacity of 20 plus alpha times 4, but process 2 then has the same. So together that's 2 times 20 plus alpha times 4, which is 40 plus alpha times 8. Since we haven't yet specified how large the desired performance level should be, we'll just leave alpha right there. But imagine that we want the capacity shortage only a few times. Then alpha would be, for example, 1.65. While if we allow capacity shortage more often, then alpha could be, say for example, 1.5. How you arrive at the value for alpha, it's not important for at least this moment. Now, if you're going to merge those two processes into a large process, it seems logical that the average demand equals the average demand of process 1 plus the average demand of process 2. So it's 40. The standard deviation for the merged process is a little bit trickier. For that, we first need to know the following. The variance, which is the standard deviation squared, but also the standard deviation is the square root of the variance. Now we can calculate the new standard deviation for the larger process, because the variances are allowed to add up. The variance of process 1, it's 16, 4 times 4. The variance of process 2 is then also 16. The variance of the new process, therefore, is 2 times 16, it's 32. The standard deviation is the square root of that number, so it's the square root of 32, which is 5.7 rounded off. So the required capacity for the new merged process, it's 40 plus alpha times 5.7. And that's less than the total capacity of 40 plus alpha times 8 that would be required for two separate processes. In this example, for simplicity, we have taken two processes with the same mean and standard deviation. However, the calculations shown work even if they are different from each other. Furthermore, we have assumed that the two processes are independent of each other. But even if they are not, there are economies of scale. However, the calculation of the standard deviation for the merged process is then a little bit trickier. More on this in a later video. The next video will be a practical one, in which I show in Excel how the economies of scale can be based on historical data and can be calculated, and where I show that it is not necessarily necessary to completely merge all processes, but that merging a part already has a huge impact on the required capacity. We will show that in Excel based on the data set, and we will make a mathematical model for it, in which you can play afterwards with the values. How much capacity do you want to have dedicated for each process, and what is the impact of sharing a little bit of flexible capacity. Hope to see you in the next video. If you are not subscribed yet to my channel, please subscribe, and until next time.